Hello everyone, welcome back. I hope everyone is doing great. My name is Ravi Teja. Let's solve an interesting problem today, trapping rainwater. This problem has been asked in many interviews and it is very important question. Okay, so let's try to solve this. So the problem statement states given an n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. Okay, so we have a city with different buildings, okay, and different heights. Okay, so whenever there is a rain there can be water trapped in between these buildings, right? So we have to determine how much water can be trapped in between these buildings. Okay, so the first building is of height 1 and second building there is no building at this particular index, and we have another building of height 2, height 1, and so on and so forth. Okay, in order to store water at a particular location there has to be higher building on its left and there has to be higher building on its right. Okay, then only a water can be trapped in between these two. Okay, if both the buildings, if surrounding buildings are at the same level, then there won't be any water stored on this particular location. Okay, the key idea is there has to be higher building on its left and there has to be higher building on its right. Okay, so that is the key idea, right? Now for any given location I should be able to determine whether there exists a higher right boundary on its, whether there exists a higher right boundary or not and higher left boundary or not. Okay, now how do I know whether there exists a higher right boundary? If my previous processed building, if it is lesser than the current building, that means I know that the current building is higher than the previous building, right? Somehow I should keep track of what all buildings I have processed, and if my current building, if it is greater than the one which I've processed just now, then the current building is higher than the previous building. If not, the current building is lesser than the previous building. That means its right boundary has to be determined yet. Okay, so the till as long as I encountered a building which is higher than its previous building, I will be accumulating all those buildings, I will be storing those buildings and whose right boundary needs to be determined. Okay, I will repeat this process until I encounter a building which is higher than its previous building, right? That means I have encountered, whenever I encounter this particular situation to this particular building, I have encountered its right boundary, correct? So whenever I encounter a right boundary for a previous building, I should also determine what is its previous building, right? So this should also be, I should keep track. So anyhow I'm keeping all of these buildings, so I should be easily able to determine it, right? So as you can see, I should be able to store the buildings in the way in which I am storing, in the way in which I am processing it, and I should be able to get those buildings, the one which is recently processed, right? The one which comes recently has to come out, right? Then what kind of data structure you can use? We can use stack, right? In stack whatever has been pushed recently will be coming out, right? So I will be using a data structure which is stack in order to determine whose right boundary has to be still determined. Okay, so let me just iterate. Okay, now I am at index 0, which is the initial building, so I will be just pushing it into the stack saying that its right boundary has to be determined, right? Now I am at index 1 whose building is 0, right, whose height is 0. That means if I see, if I compare the current height with my previous height, right, it is lesser. That means this is not a right boundary for my previous building. Okay, that means the right boundary for this also needs to be determined, right? So I will be pushing 0 back into my stack. Now I am at this particular index. Now is 2 greater than 0? Yes, it is. That means Is 2 greater than its previous element? Yes, it is, right? 2 is greater than 0. That means for my previous element, I have encountered its right boundary. So my right boundary will be 2 and I am processing 0, right? Let's say bottom. Okay. Now since my top of my stack is lesser than my current building, that means for top of my stack I have encountered its right boundary. So that is what I have mentioned over here. Since I have encountered its right boundary, now I should determine its left boundary. So what I will be doing is I will be taking 0 out of my stack and state it as have it as my bottom. Okay, now what will be the left boundary, right? So what for this particular index, what is its previous buildings, right? What is its previous building? Previous building is 1, which is actually stored in my stack, right? My stack contains the previous building for 0. Now top of my stack is 0 1, which is actually higher than 0. That means the top of a stack will be acting as a left boundary, right? So I will be having 1 as my left boundary now. Okay, now that I know my left boundary is of height 1, okay, and current building is of height 2, which is bottom, and my right boundary is of height 2. Okay, so this will be something like this. Now what will be the water trapped? Water trapped will be, water can be trapped up to the height which is minimum of left and right. Okay, up to this height only water can be trapped. If we store more than that, it will be overflowing towards left, right? So at any given point of time, right, the height will be minimum of left boundary and the right boundary, okay, minus the current height, which is the bottom wala height. Okay, now that I determined height, I should also be able to determine the width, right? How far the water can be trapped. Okay, if you see this, the water can be trapped from 3 units over here, right? So I should also be able to determine the width. Okay, how can I determine width? The width is determined by the index, okay, the bottom ka index and the current index. Okay, so the current index is basically 2 and the bottom is at index 1, so the width is basically 1. Okay, so width is 1 in this case and the height is also 1. So the water trapped will be 1 unit. Okay, now that I have determined water trapped over here, okay, now 0 has been processed, right? Now I should, now my stack contains 1, right? 1 is again lesser than 2, right? 1 is actually lesser than the current index, right? That means even for 1, 2 is its left boundary, sorry, 2 is its right boundary, so right boundary is again 2 for index 1 as well. Okay, for the bar 1. Okay, since my stack, so I will be taking 1 out of my stack, okay, and I will be having it as bottom. Okay, now my stack is empty, and since my stack is empty, that means for 1 there is no left boundary at all. Whenever there is no left boundary, right, there is no left boundary for 1 as because stack is empty, right? So I cannot store any water over here. Okay, now I will be simply processing going further. Okay, since I'm at this index 2, I will be pushing index 2 into my stack, saying that its right boundary needs to be determined. Okay, so 2 is pushed into stack. Now I will be moving to the next index. Okay, when I'm at next index, is 1 greater than its previous bar, right? Is 1 greater than the top of my stack? No, it is not. That means 1 cannot be the right boundary for 2. Now I will be pushing 1 back into the stack, saying that right boundary for 1 needs to be determined. Now I am at 0. Is 0 greater than its previous bar? No, it is not. Now that means right boundary for 0 should also be determined. Now I am at index 1. Now I am at this particular bar, right? Now this is of height 1. Is 1 greater than its previous bar? Yes, it is. That means for 0 I have encountered its right boundary. So my right boundary will become 1 and my bottom will become 0. So I will be popping 0 from the stack and I will be stating my right boundary is 2 and my right boundary is 1. Okay, I am at this particular index. Okay, now bottom is basically 0, which I have popped right just now. And what is the previous for this particular element, which is again top of my stack, which is 1. So the left boundary is also 1 over here. Okay, so as per this formula, the minimum of left and right will be 1. Okay, and the bottom is at height 0, so 1 minus 0 will be the height, which is 1. And what will be the width? Width is basically 1 minus 0, which will be 1. Okay, so again the water trapped at this particular building is basically 1 unit, so I will be having over here. Now 0 has been processed. Now is 1 lesser than my current building? No, it is not. So for this particular building, this is not a right boundary. Okay, so I will be just moving to next index. Okay, I will be moving here. Now I am at a bar of height 3. Is 3 a right boundary for its previous bar? Yes, it is, right? I missed to push 1 into my stack. Okay, is 3 a right boundary for its previous bar? Yes, it is. Okay, so my right boundary will be, I will be popping this. Okay, I will be popping 1 and it will be my bottom, and my right boundary will be 3 and my left boundary, what is the left boundary? Left boundary is the top of the stack, right? Top of the stack is also 1. Okay, so the minimum of left and right will be 1 and the bottom is also 1. That means the height is 0. Okay, I cannot store any water here. Okay, now I have processed 1, right? I will be taking 1. This one has been processed, right? So my next one is basically this one. Okay, this is my next previous. Okay, now this one is at index, I'm just processing this one. Now for this particular one, what is its previous bar? Its previous bar is 2, so the left boundary will be 2. Okay, now left is 2, right is 3, the minimum will be 2. Okay, and my bottom is of height 1. Okay, so the overall height will be 1 unit. And what is width? Width is basically the distance of this bar from the current index, which is 6 minus 3, which is 3. That means a total of 3 units will be stored, which is 3 times 1. This is the water which can be stored, right? So if you visually see, these are the 3 units. Okay, I hope you understood the glimpse, right? At any given point, I need to determine what is its right boundary. Whenever I encounter a right boundary, then I will be taking the elements from the stack, and the top of my stack will be the left boundary for the popped element, right? Now that I know my left, right and bottom, I can determine the height and width. Since height and width has been determined, I can determine the amount of the capacity of water which can be stored. Okay, let me jump back to the code and show you how I have implemented it. Okay, so as we have been given heights, right? So the length of the height, I have stored it in n, and water is the variable which will determine the total water I can store. Okay, as stated, I need a stack which will help me to determine the right boundary and the left boundary, correct? Now I will be processing my heights from left to right, that means from index 0 all the way to the end. Whenever I encounter, right, whenever I encounter a height which is greater than the height of the previous bar, or the height top of the stack, right, if the height of my current building, if it is greater than the top of my stack, okay, that means I have encountered a right boundary. So I will be taking the top of my stack and and treat it as my bottom. Now if my stack is still empty post removing this particular top, that means there exists also a left boundary. So my left is basically, the left boundary is basically the top of my stack, which is peak of my stack, right, and my right boundary is basically the current uh, index ka height. Okay, now that I know left and right, I should be able to determine the height, which is in this case uh, the breadth. Okay, the breadth is basically minimum of right and left minus bottom. Okay, my length is basically index minus the top of my stack minus 1. Okay, so now that I know my length and my breadth, I can determine the water which can be stored. So that is what I am calculating. Now that post processing the elements which are actually lesser than the right boundary, I am pushing the current index back to the stack so that the current index right boundary can be determined in the future. Okay, and then my water will contain the total amount of water which can be trapped. Okay, if I submit this, you will see all the test cases will be passed and it is pretty efficient solution as well. Okay, sorry, I just deleted this accidentally. Okay, if I submit this, let's see, it should pause all the test cases. As you can see, it has paused all the test cases and it's pretty efficient solution as well. Now if you see the time complexity and space complexity, at max we are pushing each index back into the stack and popping back into the stack, back from the stack, right? So each index is pushed and popped. Okay, so the time complexity will be big O of 2 n, so we can say big O of n as the time complexity, and the space complexity is also big O of n, where the stack can grow all the way up to the size of the array. Okay, when it can go all the way up to the size of the array, if all the buildings are in the decreasing height. Okay, 4 3 2 1, then I will be, none of the buildings has its rise boundary, because our algorithm is trying to find its right boundary first. So all the elements will be pushing into the stack saying that its right boundary needs to be determined, right? So the time complexity is big of n and space complexity is also big of n. Okay, if you like the explanation, hit the like button, hit the subscribe button. It will really motivate me to do more videos. Thank you.